2011 Relative Velocity Q.2. A woman can row a boat 4 meters per second in still water. She rows across a river 80 meter wide. The river has a flow of 3.5. She wishes to land between B and C. So you've got this question about rowing. How would she get straight across? We all probably done a few of those questions. How is she going to get straight across? What angle would she have to go in this direction at to get to B? And then there's going to be a range of values. She's going to be able to go in this direction then to get to C. She's going to have a different angle to get to C. So we're looking for this angle in here. This range of values are from this point here to this point here. The range of values that will allow this boat to finally get to between B and C. And B is 20 root 3 from C. So if theta is the direction she takes, find the range of values to land between B and C. Okay, well let's look at the first diagram we can create here. We've got the flow of the river, and we have the speed of the woman, both in speed. 3.5 t is the river, and the girl or the woman is 4t. That will enable me to get this angle. If I want to get theta there, I won't call it theta, I'll call it A, because we have a theta. But the angle I'm actually looking for is what direction is she heading in relation to the x-axis. So I'm looking for B here, which is alternate actually to this angle here. So if I use this triangle just trying to find B, I have adjacent up here, I have A, and I have H. So if I say the cos of B is 3.5, I leave out the t's, they're going to cancel, you can put them there if you want, over 4t. So the inverse cos, and that's going to be 7 over 8.5, 7 of them over 8 of them. So B is going to give us an angle of, that's going to give 28.955. I don't know how to do it. They don't ask for it. That's pretty close to 29. We'll take 29 degrees here for the angle B, and that's going to get her directly across. Okay, let's have a look. There's a couple of diagrams we can create now. We can do, I'll just change color. We have the distances, which will enable me to get another angle. We have 20 root 3 and we have 80. So that will enable me to get this angle in here. So I call this one C. We can say we have the two straight sides, so the tan of C is opposite over adjacent, which is equal to 4 over root 3. So angle C is equal to 66.586, 66.5859 or 66.6 degrees. We round it off to. Right, what's that enabling me to do? Well, let's see what this third diagram should help. We have the flow of the river, we have the speed of the woman, so we can create this triangle here with a 4t, a 3t, and now I have this angle C in here. It's not going to change. So that's my 66.6. So if I can get my angle in here up above, that will enable me to get this angle down below here, which will be the second part of my range of values for theta. So do we have enough information to get that angle? So I put my D in, we haven't called one D yet. We could say 3t over the sine of D. Oh, it's not 3t, it's 3.5, isn't it? 3.5t, 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 just be careful. 3.5t over the sine of D is equal to 4t over the sine of 66.6. So we're going to divide by t, multiply by 3.5 Get 3.5 sine 66.6 is equal to 4 sine d. So leave the sine d there and divide by 4. So this will give me what the sine of d is. Then we can get what d is. 0.80303. So we'll leave it at that. That's giving me 53.41 degrees, which I'll round to 53.4 because I see now if I add 66.6 to it, I'm going to get 110, 119, 120 degrees, which would mean that this one is 60, which means that this one is 60. So my range of values, theta started off that we could go in this direction. So it's between two values. The second one is 60 degrees, less than or equal to. The first one was 29 degrees, or if you want to round it, leave it at 28.955, but I'm going to say 29 degrees to 60 degrees is my range of values for theta here. That will get me either straight across using the T method or between B and C, so we can find out what it is at C, and then the range of values will get us somewhere in between.
I don't think I have the